Ladies and gentlemen, we cordially invite you to turn on your camera because in a few minutes, the opening ceremony will proceed in no time. Good morning, ladies and gentlemen. My name is Natasha Keniraras, and I am your host today. It is our privilege to have you with us. I would like to welcome all of you to the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020. This event is held by cooperation among Institut Teknologi 10 November, ITS, especially Department of Ocean Engineering, Tohoku University, Japan, TU Delft, Netherlands, UNESCO IHE Delft, Netherlands, and HZ University of Applied Science, Netherlands. The papers contained in these proceedings cover the topics including the field of ocean, offshore, coastal engineering, environmental and disaster management. It is an honor to me to inform you that among us here, we have Rector of the Institut Teknologi 10 November, Professor Dr. I.R. Muhammad Ashari, Master of Engineering. ISOCEEN 2020 Chairman, Associate Professor Suntoyo, PhD. Senior Director of International Activities Center, IAC, Japan Society of Civil Engineering, JSCE, Tohoku University, Japan. Professor Doctor of Engineering, Hitoshi Tanaka. The keynote speaker, Associate Professor Doctor of Engineering, Ahmad Sana, from Department of Civil and Architectural Engineering, Sultan Qaboos University, Oman. The keynote speaker, Associate Professor Alvaro Semedo, PhD, from IHE Delft, Netherlands. The keynote speaker, Associate Professor Tan Sri, Dr. Muhammad Faris Hamidi, from College of Engineering, Qatar University. The first invited speaker, the Vice President of Tuy Loy University, Vietnam, Professor Dr. Engineering Nguyen Trung Viet. The second invited speaker, Senior Lecturer of the Department of Maritime Technology, Faculty of Ocean Engineering Technology and Informatics, University Malaysia Terengganu. Associate Professor IR, Doctor of Engineering Ahmad Fitriadi. The head of HAPI Indonesia, Dr. IR Irwandi, Master of Science and the Secretary of HAPI Indonesia, Professor Dr. IR, Dietrich G. Bengen, DEA. The purpose of this forum is to create and expand the professional network to foster the relationship between the university, industry, business, and communities across the globe. The main agendas of this event are opening speech, presentation by keynote speaker, discussion, parallel session, and closing ceremony. Ladies and gentlemen, to start this event, we will listen to the national anthem Indonesia Raya and continue with the ITS hymn. Let us start the event. As the chairman of ISOCEEN 2020, Associate Professor Suntoyo PhD will be delivering the welcoming speech. Ladies and gentlemen, please welcome Mr. Suntoyo.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Good afternoon, President of Allah Subhanahu wa Taala, a grace that has given favor and gift in this afternoon. The first that we respect, Rector of ITS, Professor Muhammad Azhari, Dean of Faculty of Marine Technology, Dr. Eng Trikapitana, Head of Department of Ocean Engineering, Dr. Hirman Pratekno, and Senior Director International Activities Center, Japan Society of Civil Engineering, Professor Dr. Eng Hitoshi Tanaka, representative of Indonesian Coastal Management Expert Association, and also Indonesian Coastal Engineering Expert Association, distinguished keynote speakers, and Professor Dr. Eng Hitoshi Tanaka from Tohoku University, Japan, and Associate Professor Ahmad Sana, PhD from Sultanate Kabul University, Oman, Associate Professor Alvaro Semedo, PhD from ISE UNESCO, the Netherlands, Professor T.S. Dr. Muhammad Faris Kamidi, Qatar University, Qatar, and invited speakers, Professor Dr. Eng Nguyen Trung Viet, Vice President to Loy University, Vietnam, and Associate Professor Dr. Eng Ahmad Fitriadi from University Malaysia, Terengganu. Lecturers within ITS, contributing authors, seminar delegate, expert, scholar, all students, ladies and gentlemen. Welcome to the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020. I am pleased to join here today. We are collected to announce that this international seminar was initiated by a collaboration between ITS, especially Department of Ocean Engineering, and Tohoku University. At the time, Professor Hitoshi Tanaka initiated a conference or seminar, and together with my colleague from Tohoku University. And that have collaboration since 1997. In the year of the 2006, a memorandum of understanding, MOU, has been signed and then extended between Tohoku University and ITS, especially Department of Ocean Engineering. And to promote further collaboration between two universities, many activities that have performed will, in terms of collaborative research, faculty and student exchange, joint educational program, seminar, and etc. Especially for the seminar and workshop has been done before. For example, the Japan-Indonesian workshop on estuary and climate change at the 2010. However, the previous seminar activity organized not regularly or annually. Therefore, since 2013, has been held an annual seminar entitled the first international seminar on ocean, coastal engineering, environmental and natural disaster management, ISOCEEN, on November 11, 2013 at Surabaya, Indonesia. With the increasing amount of cooperation between Indonesia, Japan, Netherlands, and other countries, then this forum is more focused on creating and expanding professional network to foster the relationship between the university, industries, business, and communities across the countries. This year, again, we are proudly to announce that ITS, in collaboration between among the Tohoku University Japan, ISE Netherlands, Heidstad University and Applied Sciences Netherlands, Novik International Education Netherlands, jointly organizing the 8th International Seminar on Ocean, Coastal Engineering, Environmental and Natural Disaster Management. Within webinar or virtual seminar in Department of Ocean Engineering, Faculty of Marine Technology, Institute Teknologi 10 November on 27 to 28 October 2020. This seminar also supported by Indonesian Coastal Management Expert Association and also Indonesian Coastal Engineering Expert Association. In this seminar, with 4 keynote speakers, 3 invited speakers, and 55 regular talk contributions from over 120 participants from 12 countries, namely Indonesia, Japan, Netherlands, Oman, Qatar, Germany, Portugal, Spain, Vietnam, Malaysia, and Korea. And participants of this seminar come from 14 foreign universities and 12 domestic universities, 6 research center or agency for the assessment and application of technology, 4 overseas research center. Selected paper will be presented in the ISOCEEN 2020, will be published in the IUP conference series, Earth and Environmental Science, Index in Scopus. Finally, on behalf of the organizing committee, the seminar, I would like to warmly thank all the authors who, with their presentation, generously contributed to the lively exchange of the scientific information that so vital to the endurance of the scientific conference of this kind. And special thanks are also due to all keynote speakers and all committee for the effort in preparing the manuscripts and managing the session respectively. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, sir. Next, as Director of the Institut Teknologi 10 November, Professor Dr. I.R. Muhammad Asyari, Master of Engineering, will be delivering the opening speech. Ladies and gentlemen, please welcome Professor Muhammad Asyari.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, ladies and gentlemen. Welcome to ISOCEEN 2020. The Honorable Dean of Faculty of Maritime, Dr. Trika Pitana, the Honorable Chairperson, Dr. Suntoyo, and also the Honorable Head of Ocean Engineering Department, Bapak Herman Pratikno, PhD, the Honorable Senior Director, International Activities Center, IAC, Japan Society of Civil Engineering, Professor Hitoshi Tanaka. Good afternoon, but probably late afternoon for you, another 3 hours behind Indonesia. And distinguished keynote speakers, Professor Hitoshi Tanaka as well, Associate Professor Ahmad Sana from Sultan Qaboos University, Oman, also Professor Alvaro Semedo from UNESCO, Delhi, Netherlands, Professor Muhammad Faris Hamidi from Qatar University, also all invited speakers, and also senior leaders and lecturers and researchers who attending this conference. It is great pleasure to meet you in this international conference, the 8th or after 8 years international seminar on ocean and coastal engineering, environmental and natural disaster management, ISOCEEN 2020, that this is the 8th of the seminar. It's good pleasure. It's very thank you for Department of Ocean Engineering of ITS that can maintain this conference, this seminar with a very good keynote speech, expertise with diversity countries, as mentioned by the chairperson, Dr. Suntoyo. I wish to warmly thanks to the host of this dedication and preparing the importance of international seminar in this event. As we know, the international conference, international seminar like this conference, it's very helpful to improve the international environment in ITS. As we know, ITS, Institute Teknologi 10 November, 10 November means 10th of November, there was a big battle in Surabaya in 1945 after Independence Day. This we use as the name of this university. This university, ITS, was established in 1960. It was ceremony by the first President of Indonesia, Insinyur Soekarno, and this university, ITS, was established especially dedicated to support the maritime of Indonesia. And until now, up to now, we still very strong in maritime, in ocean engineering, that the host of this conference today. Now, ITS will, I think next month, we will have a 60th anniversary of ITS after establishment. And we are happy that this conference, this seminar is part of our celebration of 60th anniversary of ITS. And today in ITS, we have 7 faculties, 20,000 students, 1,000 faculty members, and then the position of ITS in the world university ranks according to Times Higher Education. The position in Asia is 200.1. In Indonesia, the position is ITS is the 3 best university according to Times Higher Education. Ladies and gentlemen, all distinguished participants, we hope that this forum, this seminar, is more focused on creating and expanding professionalist network to foster the relationship between the university, industry, business, and government. As I mentioned, our university ITS is very strong in maritime, in ocean engineering. We already serve to design, to improve, to provide many ship, many vessel for government requirement. until now, we still serving many kind of vessel or ship or maritime asked by the Minister of Transportation of Republic Indonesia. So we hope that this conference, will fruitful to improve, to invent, to innovate any technology regarding the maritime. Not only maritime, but also the environment, the sustainable science and technology onshore, ocean, and also coastal engineering. Finally, I would like to express our gratitude to all speakers, all distinguished keynote speakers, invited speakers, and all committee for contributing in our seminar. Special thanks are also for all invited speakers and committees for the effort on preparing the manuscript and managing the session respectively. Thank you very much. Happy seminar, happy conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Mr. Muhammad Ashari for your very delighting welcoming speech. Before entering first session speech, we will have a quick photo session. To all audience, please turn on your camera. Thank you very much for your cooperation. Now, this is the time for us to enter the first session speech from our keynote speakers. We are very privileged to have him as our first guest speaker today, Professor Doctor of Engineering Yutoshi Tanaka, Senior Director, International Activity Center, IAC, Japan Society of Civil Engineering, JSCE, Tohoku University, Japan. The second speech will be delivered by Associate Professor, Doctor of Engineering, Ahmad Sana from Department of Civil and Architectural Engineering, Sultan Qaboos University, Oman. This session will be guided by Professor IR Widi Agus Pratikto, PhD, as the moderator. To Professor Widi Agus Pratikto, the stage is now all yours.
Okay, thank you, the MC. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
I'm sorry for the dynamic of the background because sometime on, sometime off. But we try the best that we provide with the background of the ISOCEEN. First of all, the first session will be first speaker, Professor Hitoshi Tanaka, the Senior Director of International Activity Center. I think we were having a long partnership with him. And the second one will be Associate Professor Dr. Ing Ahmad Sana. I think that will be served for from 13:14 up to 14:15. That means 1 hour. So you might have like 15 minutes or 20 minutes each, and then that will be question and answer. I will be happy to have Professor Hitochi coming first, delivering his speech. Time is yours, Prof. Hitochi.
Yeah, thank you very much for your kind introduction of myself. And Selamat siang, distinguished guests, ladies and gentlemen. Good afternoon. It is my great honor to give a lecture here. And first of all, I'd like to express my grateful thanks to Dr. Suntoyo for his kind invitation. And also, I wish to celebrate 60th year anniversary of ITS. Okay, so let me share the, can I share my PPT file? It is not allowed. Someone responsible for this connection? I cannot upload. Okay, now it is. Can you? Is it okay? Yes. So I need to start my lecture. My talk today is the sea bottom boundary layer and with shear stress and tsunami. As you all know, we had a very serious and devastating tsunami disaster in Japan about 10 years ago. And as you can see here, there was a very serious disaster in Japan. And similarly, in the year of 2004, the Indian Ocean tsunami occurred in Indonesia. So we are sharing the same natural disaster due to tsunami. So that's why I took this topic for my keynote lecture. So this is one typical erosion in Japan along the Sendai coast. Before the tsunami occurrence on March 12, we had a very smooth shoreline, very nice environment along the coast, but it was seriously damaged by tsunami. And after some time, there was a recovery process along the coast, but it's still, even now, in some places, more serious impact is remain along the coast. And I'd like to introduce numerical simulation for such a morphology change induced by tsunami. It is very, very common to use the shallow water equation to make a numerical simulation for tsunami. And from that hydrodynamic modeling, we can calculate bottom shear stress. Then coastal morphology change can be predicted using numerical model. But there comes a question about numerical simulation. As you can see here, the wave hydrodynamics can be classified into short period wave and the longer period wave. And for the latter, we can use our water equation, but we don't know what's the corresponding friction factor for tsunami wave, right? We simply assume that for long wave, because it is long wave, we can use the steady friction factor, as you can see here on this slide. But no one knows whether demarcation will be located here or here. And there's a possibility that even on the long wave motion, the steady friction factor cannot be used. And there come the scientific questions: how to define the demarcation criteria for friction law under tsunami, and clarify the characteristic of boundary layer and a bottom shear stress beneath tsunami waves. This is a motivation of our research activity for this topic. And this is a diagram I just took from the textbook for undergraduate student. And as you all know, for steady flow, we can use this kind of friction factor diagram, which is commonly called the Moody diagram. Although it has been initially proposed for circular pipe flow, but it can be applied for open channel as well. And normally we use the Manning-N, which is equivalent to rough turbulent friction factor in this diagram. And as you all know, there's a totally different friction diagram for wave motion, right? And for example, for rough turbulent regime, we have totally different represented lengths. There is a AM, there is a water particle excursion length and a wave motion. So like that, comparing a steady friction factor and the wave friction factor, the representative length is totally different, whether it is water depth or the amplitude of water particle excursion length. So the problem here is how to define the demarcation criteria for friction law, whether steady friction law or wave friction factor under tsunami numerical simulation. Before I explain the detail of this research, let me introduce the tsunami-induced morphology change in Japan. First of all, let me introduce the devastating morphology change on Rikuzen Takata coast. As you can see here at the top, the pre-tsunami situation was like that. Very nice sandy coast with the very dense pine tree forest in this area. But as you can see at the bottom, the sandy coast as well as the pine tree forest disappeared completely due to tsunami. And at some place here, there is only one pine tree remained after tsunami. This pine tree is called Miracle Pine, a lone pine tree that stood as a symbol of hope. So anyway, there was a project to recover this sandy coast. Of course, due to natural process, it is impossible to recover the sandy coast. So we had a project of recovering sandy coast. And not only sandy coast, but also constructing the embankment, as you can see here, which has a height of more than 10 meters. Because in this area, tsunami height was more than 10 meters. So that's why the height of the embankment is about 12 meters. And as I mentioned, the sandy coast completely disappeared. So they made a plan to create a beach again, and also plantation of pine tree on the sandy coast. And this is the plan of beach nourishment in this area. And not only the sandy coast, but also immersed breakwater has been reconstructed. Even after the tsunami, we had immersed breakwater, but it was seriously damaged by tsunami. And in our technical committee, we made a detailed discussion what kind of sand can be used for beach nourishment, and making a comparison between the original sand and the borrowed material. We decided to use the sand, as you can see here, which had the similar diameter and a similar color as compared with the initial sediment. And embankment construction has already finished. The height is more than 10 meters. And as you can see at the bottom, the beach nourishment has already completed. So this was a very, very big project. And let me introduce some other examples of serious beach erosion. As you can see here, there was a very serious erosion, but very interesting on the left hand side, almost no change. Even during so extreme tsunami, only the right hand side of the sandy coast was seriously eroded. According to our detailed investigation, this is due to difference of structure. I will skip the detail of this explanation. And this is another example of very serious erosion. As you can see here, very serious breaching happened on the sandy coast. But gradually, with the passage of time, the natural recovery happened. And like this, it took more than 2 months for the complete recovery of the sandy coast. This is another serious erosion on Sendai coast. And longshore sediment is moving from the right to left, and due to tsunami, a very serious erosion. But after some time, recovery happened. But too much sediment supply caused the complete closure of the river mouths. That was another the problem, a natural disaster in this area. So as you can see here on the right-hand side, a gradual shoreline advancement happened after serious erosion on this coast. As you can see here on the left-hand side, the sediment was eroded on the both sides of seriously eroded area, and very serious retreat on both sides, on the right-hand side and the left-hand side can be seen because the sediment was supplied to the eroded area, in the concave shaped area. Okay, this is another example of serious erosion, but I will skip the detail. This is another place with very serious erosion of river mouth sunspit, and even now, nothing happened. Even now, the river mouth is totally open without sediment deposit. So like that, after tsunami, there are many various response in many situations. And here it is very, very serious problem of no recovery of sunspit at river entrance. This is also a very serious place. As you can see here on the right-hand side at the top, there was sandy coast and a very dense the pine tree forest, but it completely disappeared, very seriously eroded. According to the field survey in this region, the maximum water depths induced by the serious erosion by tsunami attained to more than 10 meters, something like that. Right? So even now, almost no recovery. And this is showing the numerical simulation result. As you can see here, very high tsunami propagated along the river that caused a very, very serious erosion, especially in the sandy coast near the river mouth. This is a air photo before tsunami and after tsunami. The very gradual, very slow recovery can be seen. And even now, the situation like that. On the right-hand side, this is the most updated morphology. Right? Almost no recovery of the sunspit at the river entrance. Like that, still very, very serious problem remain in many places. Okay, now I will come back to our study about tsunami-induced bottom shear stress. I explained already about this diagram. We know the demarcation between the short period wave and the long period wave, but we don't know where demarcation is for friction law. So that is our motivation of the present study. And there are two scientific questions. What is the demarcation and what is the characteristics of the bottom boundary layer and the tsunami? Now let me make a brief literature review of this topic. In the past computation, it is very common to use a mining N or wise buffer F for numerical simulation. And although it is a long parallel way, the flow motion is fundamentally the unsteady. So no one knows whether steady friction factor can be applied or not. And in 2016, the research group in the Technical University of Denmark made a detailed numerical simulation for tsunami boundary layer using K omega turbulence model. And they found that the tsunami boundary thickness is about 1 meter, which is very small as compared with the water depths. So that means the steady current friction factor can be utilized for tsunami. And there have been several the studies for solitary wave boundary, including ours, and we found that the unsteady characteristics is highly predominant even under long wave. And this is a brief introduction of our study. In this diagram showing the water depth variation from the tsunami source area. The left-hand side is the tsunami source area with a depth of 4,000 meters. And we input the tsunami wave at this end, and we calculate the tsunami propagation process from the left to the right. And this is the computed boundary thickness. As you can see here, tsunami boundary thickness is very, very thin as compared with the water depth, which is 4,000. Right? This is a ratio between the boundary thickness and the water depth. It is very, very small. That means the steady friction factor can be used. And with the propagation of the tsunami to the onshore direction, tsunami boundary layer develops, and also water depth decrease gradually. So this ratio come to the value about 1.0 near the shoreline. And this is showing the comparison between the boundary layer from the wave theory and that from Manning's method. As you can see here, Manning's N underestimate shear stress under tsunami. This is a very, very important fact because shear stress or shear stress induced wave energy attenuation affect the wave height of tsunami, and also sediment movement induced by tsunami. Right? So this is a very, very important result in connection with the tsunami disaster prevention planning. Yeah. And the motivation in our study is what friction law need to be used in tsunami numerical or simulation. In shallow water area, there must be boundary development or up to the water surface. Okay, so we can use the steady flow or friction factor such as Manning N or wise buffer, whatever. But in deep area, how to evaluate the bottom shear stress? That is a big problem clarified from our previous study. So in our study, we use the K omega turbulence model for hypothetical shoring tsunami. It's a bit complicated mathematical equations for K omega model. Anyway, we use this model in a vertical direction to obtain the velocity profile under tsunami. And in the tsunami source area, we are showing that the tsunami height is 1 meter, and the water depth is 4,000, and wave peril is 15 minutes. And for tsunami shoring process, we can use the very, very well-known green theorem, as you can see here. And also, tsunami-induced velocity can be calculated using the linear shallow water theory as you can see here. And according to this equation, the velocity under tsunami is inversely proportional to water depth. So if we have so deep water depths as 4,000, the tsunami-induced velocity will be very small, right? And in our numerical model, we assume this grain size, which is 0.3 millimeter on the bottom, and we made a detailed numerical simulation for these 4 cases for water depths of 4,000, 1,000, 100, and 20 meters, getting shallower and shallower to the direction of shoreline. And this is a very well-known diagram for applicability of wave theories, deep water wave, intermediate wave, and shallow water wave. And this indicate the breaker line for wave motion. And as you can see here in this diagram, our 4 cases from case 1 to case 4 belong to long wave, because water depth or wavelength ratio is smaller than 0.05, and under these 4 conditions, the wave height is much smaller than the breaker limit. Okay, I will show for numerical simulation result. This is a computation result for offshore boundary. That is a tsunami source area with a depth of 4,000. And as you can see here, the velocity profile is shown here, and the vertical axis is normalized by water depth. As you can see here, the bottom boundary area is confined in immediate vicinity to the bottom, right? And when we use the Manning end, we assume that the velocity profile might be similar to open channel flow, but as you can see here in this diagram, velocity profile is totally different from that in open channel flow. And because of this velocity profile, the Manning end steady friction factor gives the too much underestimated shear stress. Right? According to our computation, the about 6 times difference as compared with the steady flow or estimation. This is very important, that using the Manning end, we will underestimate the wave energy or dissipation process. Okay, now let's come to the water depth of 1,000, which is located somewhere here. In a computational domain, it is rather shallow area with a depth of 1,000, but still the boundary layer is located in the immediate vicinity of the bottom. So resulting in the underestimation of the bottom shear stress, as you can see in this diagram. Very big difference between steady computation result and our computation result. Even at the 1,000 water depths, such a big difference can be seen. Okay, next we come to the water depths of 100, very close to the shoreline, but still the boundary layer thickness is about 1% of the water depth, resulting in the underestimation of shear stress using the steady friction law. Okay, now let's move to the most shallow place, which has the 20-meter water depth. But still, the underestimation of shear stress can be seen using the steady friction factor. So like this, even after the location of 20-meter water depth, the Manning end cannot be used for tsunami numerical simulation. This is a very important new finding from our study. And
Prof. Tanaka,
yes,
your time is up.
okay. So then finally,
yes, please.
Okay, so finally I will conclude my presentation. Important result is that in the shallow area, the steady friction law can be used, but in a deeper area, it cannot be used. And yeah, our four cases belong to this area in which shallow water equation can be used, but the steady friction factor cannot be used. Okay, thank you for your kind attention. This is the end of my talk.
Thank you very much. We appreciate for the paper. Ladies and gentlemen, Professor Tanaka have title Tsunami-Induced Morphology Change due to tsunami. So please, time is yours for giving 20 minutes for material and then 10 minutes or so for having question and discussion. Time is yours, Prof. Sana.
Thank you very much, Professor Vidhi. I would like to thank my dear friend and previous colleague, Professor Suntoyo. And also I see my supervisor, Professor Tanaka here. So very hard for me to speak in front of him, but anyway, I shall try. So let me just present my presentation here. Okay, I can share. Okay. I hope everybody can see my screen. So the topic today that I want to talk about is the measurement of seawater quality and hydrodynamic parameters along the coast of Oman. That was actually a funded project from the Ministry of Environment and Climate Affairs. Now it is called as the Environment Authority in Oman. This work was jointly done by a lot of members from our research team and our recent doctoral degree graduate, Prerna Chitrakar. She finished her PhD using the information that I'm going to present today. So she worked on the data analysis. Of course, data gathering was a big task. So it was a teamwork, but she did most of the analysis that I'm going to present today. First, I will just talk a little bit about Oman. And as like a lot of people, they might not know because it's a small country just on the eastern edge of Arabian Peninsula. The reference, of course, can be given by Kingdom of Saudi Arabia, which is on our west side, and northern side, northwest side, we have United Arab Emirates, and in the south we have Yemen. So these three countries are, of course, very well known. And in Oman, we have about 11 what they call as regions, governorates, they call them. And out of these 11, 7 of them are actually having coastline. So a lot of activity on the coast. The length that has been measured by different scales is of the order of 3,000 kilometers. And we have, as you can see, let me just try to use my pointer. So as we can see here, this part at the tip of this Oman Sea and Arabian Gulf, we have Musandam, that is also part of Oman. In between, we have UAE as well. So this is briefly about Oman. We have very small population, about 4 million. Area is quite large considering the Arabian countries. So it's like 309,000 square kilometers. We have just to show you a little bit of interesting bathymetric features here nearby. So we have here Sea of Oman, previously known as Gulf of Oman, and we have here Arabian Gulf or Persian Gulf. It depends on from where you are speaking. So if you are from Iran, then definitely you would call Persian Gulf. If you are sitting in an Arab country, then you will be calling it as Arabian Gulf. Here we have Oman, and we can see very interesting features here in the bathymetry. So the depth here is like of the order of 3,000 meters, and it within about 3 to 400 kilometers, it reaches about 40 meters. So very steep slope when the seawater actually enters or leaves the Arabian Gulf here near the Musandam Peninsula. So this is the Strait of Hormuz. I hope everybody knows about it. Here we have some other interesting features, which are like one of them, Murray Ridge, which is very famous here in this region. Then Dalrymple Trough is also there. So they affect the circulation in this area. So a lot of these features are interesting here. Here we have somewhere here, Indus enters into the sea, and this whole area is like the sediment, mainly it is coming from the Indus River. So this is the name of this area. They have named it as Indus Fan. Then there are some interesting circulation features which are taken by the satellites. So here we have Ras Al Had jet, which is very famous circulation feature in this area. They call it Ras Al Had front as well. There are two big like gyres, eddies, which are here, and the circulation pattern actually shows in this map. In fact, the chlorophyll A concentration is shown, which was taken by the satellite image. This image I have taken from NASA's website. So here, as we can see here, very strong presence of dense chlorophyll A near the shoreline. And actually, when we did some measurements, we also found similar features in our coastal measurements, because most of our measurements are near the coast. So here, like just in this figure on the right, it shows some of these features which I just talked about. Then the measurements, like of course the measurements were supported by the government, and they are interested to have like permanent monitoring facilities along the shoreline. They wanted to have some baseline measurements along the shoreline, where especially where some of the existing structures are, which can cause environmental problems. So we chose these 12 stations. Most of the activity is actually on this coast, which is northern side, which is called as Al Batena coast. There are a lot of activities here from coastal engineering point of view. Then we have recent activities here at Duqm. A very big port has been constructed. There is a dry dock and a refinery as well. Shuaimia is like a kind of so far is a kind of passive area from a development point of view, but there are going to be planned activities in future. Taka is again is a very active area here. There are a lot of coastal structures and coastal establishments are there. So a lot of activities in all these points. So that was actually one of the consideration while selecting these measurement points. So I'm sorry, because of the time and because of the space, I probably there will be some confusion. So, but I can answer the questions later maybe. So I will just rapidly go towards what we have done. As I said, these are the pictures from our selected areas. So all these areas, in fact, they have some coastal features. So whatever picture you see there, we have located one of the measurement points there. The major activities, as you can see, they are either shipping ports or the fishing ports. There are desalination plants and power plants as well, like a combination of power and desalination. That is mainly in Barka area. Then we have Al Ghubra desalination plant as well. We have some aquaculture in the open ocean near Khuriyat. So we have done some measurements there as well. There is a fishing port also. In Muscat area, which is close to Muscat, is Mina Al Fahal area, where we have the biggest refinery of the country. And we have a lot of activities, port activities here. Then we have Dukum, as I said, that's the new port which has been constructed, just completed within a couple of years. And then we have Taka, which is in the south. We have some ports, fishing ports, as well as desalination plant and power plants there. Shoemia, as I said, is so far not many development has been taken place. So this point could be like considered as one of the control points, which like in the natural environment. So the equipment, of course, is well known. This is the boat that we used. This belongs to our university. It's a small vessel, research vessel that we have. We deployed the current meters. The current meters was basically from Nortec. We had about 4 units, so we deployed them at various places, and we kept them for generally for about 2 to 3 months, but a few places we kept them for longer duration in the sea. Here you see the CTD as well. So CTD was used for the in situ measurements of some of the water quality parameters, but we took samples as well, and we brought them to lab and we analyzed them there. So all these activities, of course, we took samples with respect to depth in the near the top and in the middle and in the kind of bottom, by using this water bottle, where we can control where the sample has to be taken. Some of the parameters that we measured here and how we analyzed them, that is like some of the simple measurements were like temperature, salinity, dissolved oxygen, chlorophyll A. These were measured in situ by using CTD. And all the other things like, for example, EC values. Of course, EC was in situ also, we measured it, but we did BOD, COD, and most of the other like water quality parameters were done in the lab using the equipment there. The biggest trouble, as we know, that is heavy metals, because they have very small or very low concentration in seawater. So for that, we had to use ICP OES. So like some of the equipment that our university has. Some of the, of course, I'm sorry, it's a lot of data and a lot of abbreviations as well, but I will try to just highlight the features that are important in my view. Of course, I shall be able to answer other questions later. So Ghubra, as I said, there is a desalination plant, so temperature in this area is generally, it is high. But of course, I cannot 100% say that, because of the weather or the time in during the year, because some of the measurements were in the summer, some of them were in winter season. But in general, like we can see that close to the desalination plant, we had higher salinity, we had higher temperature. Similarly, for dissolved for EC, similar pattern, because of course salinity is dependent on EC is dependent on salinity. Of course, for the chlorophyll A, Dukum area is we found high values there, and I shall talk about it a little bit later, that what could be the reason. But one of the factors that we have seen before in the NASA image, that near the coastline in that area, they have reported higher chlorophyll normally in that situation. So dissolved oxygen in general was good, but it's kind of serious in some of the places where it is less than 2 milligram per liter. And if it is below 2 milligram per liter, then the the aquaculture is actually in a big trouble. Like marine animals, they start dying if the dissolved oxygen is much less than 2 milligram per liter. So in some of the places we had this situation. Similarly for BOD, then again BOD is found to be higher near Kurayat, and in Kurayat, as I have shown before, that there is aquaculture activities going on. So that could be the reason for this higher values. Similarly, the phosphorus, which is again related to the waste of marine waste. In other areas, of course, we can see that these water quality parameters are not that high. Total coliforms in Sohar area were more, which shows a little bit of presence of the wastewater. And similar is here, like for the E. coli, we found higher concentrations near Sohar area. These are some of the profiles of temperature which were done by CTD. Some of them, they were done in winter, like February, and some of them were done in summer or spring. So as we can see here, in interesting features, of course, we can see close to Barka area, as well as Ghobra area, where the desalination plants are there. So we have very nice stratification. In the upper layers, the temperature is quite different from the lower layers. In general, in lower layers, the temperature ranges from 24 to 26 degrees, whereas the top layers, we have water ranging based on the season. It can be up to 30 or 31 degrees. Similarly, the salinity profile, again, the interesting feature that we can see is from at Ghobra, where the desalination plant is, and we see higher salinities, although the difference is not much, but it's about 1 unit, 0.8 to 1 PSU. Which is like higher than the rest of the places. But in most of the places, as we can see, the salinity is within 36.6 to 36.7, about that range. Another thing is dissolved oxygen. As I mentioned, at some of the places, we saw that the dissolved oxygen values are quite low. Most of the places it is about 6, which shows a healthy marine life, but the values which are less than 4, the marine life is under stress, and if it is less than 2, it is quite disastrous for the marine life. So we have seen in some of the places such type of situation is there, and most of these places where the situation is actually adverse is close to some of the coastal projects. Like Mina Al Fahal, we have a very big refinery, and a lot of activity is there from coastal engineering point of view. For chlorophyll A, again, the interesting features are near Dukum, where we have higher chlorophyll A values. And we can see upwelling phenomena as well. Mostly higher chlorophyll A concentration is close to a depth of 10 to 15 meters below the sea surface. But here we have at higher elevations or at shallower depths, we can find higher value of chlorophyll A, and such interesting features also can be obtained from these measurements. Then some of the heavy metals and the petroleum hydrocarbons, which are shown here. Again, I'm sorry for the abbreviations used here for the stations, but there is quite a lot of data, so I wanted to show most of the things here. At Mina Al Fahal, which is where the oil refinery is located, we can see that like the things which are there, like total petroleum hydrocarbon is higher near that area. And total petroleum hydrocarbon we measured in like different categories, like gasoline rate range carbons, then diesel range carbons, and then heavy fractions as well. But this is the total total petroleum hydrocarbon which is shown here. Otherwise, in most of the places, the values are less than the trigger values. And again, another topic of discussion is the trigger value, which is based on international organizations. We used a set of values from different organizations because we don't have that much detailed values for all the trace elements and the petroleum hydrocarbons in Oman from environmental point of view. So that's why we use different values from other countries as well. But as we can see in most of the situations, the values that we have measured or we have monitored, they are less than the trigger value. So like the water quality is not that bad, except for example for lead, which is an indicator of the presence of petroleum. One of the indicators, of course, it can be from geological origin as well. At Mina Al Fahl, we have higher values than the trigger value. Similarly, for some of the other things, most of the time the trigger values are higher than the one we observed in our case. But for nickel, we found now this data is about the sediments, so it's not from the water quality, but from the sediments. So from the sediments, we can see some of the places we have higher values of the as compared to the trigger value, we have higher values of these trace metals. Especially nickel is higher at many places in our area. Same thing for the some of other selenium, which is again much higher than the trigger value. Lead at Duqm is much higher, and that one of the possible reasons, may, of course it can be from geological, we are not sure yet, but it one of the reasons can be because it has a dry dock and ship repair takes place there. So that higher content is probably because of those activities going on in the port. Same thing for some of the other things. Zinc is higher at Sawadee, which is of course contributed to the attributed to the shipping or boat repair activities which are done in Sawadee area. Some of the results which we obtained from historical measurements from other researchers, so we just compared them with our measurements which we did in 2019. So some of these results, which are from the previous years, they are from literature, and we see that overall the situation, it was much worse in 2015, but it is getting better. Although some of the lead quantities or lead concentration seems to be higher now in most of our places here, but other than that, most of the trace elements are within the range of the international values in other oceans. Total petroleum hydrocarbon, which is shown here, again, it is of the order of the same value as reported before, a little bit lesser as compared to the previous years. Then I just want to show some of the hydrodynamic measurements that we did by using Nortec ADCP AVAC. Of course, there can be a lot of discussion on that, but I will just briefly describe some of the things that we have done. As I said, we deployed the current meter at different places for a period of 2 to 3 months. But in this area, Mina Al Fahal, just opposite the petroleum refinery, we did a lot of deployments because of the interest of some other groups, research groups in our team. So we have quite a lot of data for that. And also for Barca, it was a little bit longer duration we deployed it. So all these measurements are based on this, or the data analysis that we have done, it is based on the duration that we have used it for. Just the velocity profiles here. These dashed lines are basically the power law velocity profiles. Of course, perfect matching is not possible, and we haven't yet analyzed it completely, but some of the features can be seen. We can see kind of a distinct log profile from the data here, which I think is not very much discussed in our report, but we are still working on it. Most of the areas we have the current average current of the order of 0.2, but in some of the places higher currents are also observed during the time period that we deployed our current meter. For example, Mina Al Fahal, higher current during the period of deployment. Of course, I cannot comment on the other seasons because of the lack of the data there. Then higher currents are observed in mostly in the southern area. In Qurayat, we have higher currents, and it is well known for that area as well. Then we have some wave height measurements from ADCP as well. So this graph again, it shows kind of averaged values. So monthly averaged values and the station averaged values, they are shown in the dashed lines here. So the significant wave height is shown here mostly, and the peak wave period is shown, as well as the maximum wave height which we have observed during the period of deployment of each current meter. So at Mina Al Fahal, we can see mostly in Shuaimia we have higher waves, at Dukum as well. So all these are like Qurayat as well. These are in the southern part, which is in Arabian Sea, and which is of course logical because of the open ocean. We have higher wave heights there. These areas like Barka, Ghobra, and Mina Al Fahal, they are located within the Gulf of or Sea of Oman on Al Batina coast. So we have lower wave heights and also the peak wave periods. So these are like averaged values for them. This shows a kind of trend of the frequency of the significant wave height for our measurement stations in general. In most of the stations, as I said, in case of the Al Batina coast, we have lower wave heights. So most of them are in the range of 0.4 meters. And then we have higher waves mostly in the southern part, in the southern area, which is which goes to the Arabian Sea. So this situation is there as well. Similarly, for peak wave period, some of these values are there. Um, Wave distribution at like the direction, especially mostly the waves in the southern stations, they are coming from south and southeast, and in other stations which are in Al Batina, they are coming from northeast directions. So that's again, it compares well with the measurements by other colleagues in our field. This just shows distinction between the swells and the short period waves based on one of the criteria, that if the wave period is like peak period is about 8 seconds, so within that will be short period waves, and then higher than that will be swells. Which means the waves are actually coming from some other area. They are generated somewhere else and then they are reaching in that area. But of course, the wave height of swells is kind of very small as compared to the waves which are generated in the area. This again shows a little bit of pattern of the tidal elevation, water surface elevations, and wind vector, and in response to that the current vector as well. So current vector is plotted at two locations, one slightly close to the water surface and another one little bit deeper. So we can see some of the interesting features here about in consideration with the wind vectors. So in general, the current pattern near the surface follows the the wind pattern, but in some of the places we can see that there is a huge difference between the current and the direction of the current and the wind. So that these interesting features are also there. So we are still working on the numerical model to kind of address these findings to see how this is happening. And then of course the significant wave height and peak period is also shown here. So on the right hand side you have the wind rose and the wave rose, like the wind speed and direction and wave height and direction is shown. So this is done for Kuryat as well, because Kuryat is another interesting location. So as I said, in some of the times, the wind and current are kind of in the same direction, as we can see here and in this location and here as well at this time as well. But in some of the places, it is totally opposite to that. Same thing with the Shuemia. But of course, probably you have noticed that we have a mixed type of tide. In the northern part, we have mixed with the more of a semi-diurnal type, but in southern part we have a mixed but with the diurnal features predominant. Just coming to the conclusions. So as I mentioned before, in most of the situations, dissolved oxygen is fine, but in some of the places, it is less than 2 milligram per liter, which shows a serious situation for the marine life. The salinity close to the desalination plants is slightly higher, which can cause as well damage to the marine life in that area. Phosphorus values, phosphate values at Kuryat, of course, again indicates the because of the activities, aquaculture activities there. So that shows that information in our measurements as well. Chlorophyll A at Duqm is higher, which again corresponds to that NASA image as well. And Khabura and Sohar, we have high values of total coliform and E. coli. That also shows the microbial contaminations there. Lead higher at Duqm shows kind of probably the activities which are done there for repair and maintenance of the shipping vessels there. Similarly, most of these things are there, but as the highlight of this conclusion is that most of the detected concentrations of heavy metals, they are fine as compared to the other places, located in the world. In the hydrodynamic measurements, only brief conclusions are there. Just the range of currents are like in upper surface is about 0.3 meter per second, and towards the south of Muscat, and 0.2 meters per second towards southeast at the southern coastal stations. Most frequently occurring waves and significant wave heights, as I have mentioned before, they are in the smaller range, and the peak wave period are in the range of 2 to 6 seconds. So just I want to acknowledge the funding by the Environment Authority, formerly Ministry of Environment and Climate Affairs, Oman. And thank you very much for listening. I'm sorry, I probably have caused more confusion than showing you some information, but of course I will be happy to answer the questions. Thank you very much.
Thank you very much, Professor Sana. Measurement of hydrodynamic parameters and seawater quality along the coast of Oman. So that will be question and answer as well as discussion. And from the committee, it was said that the time will be up to 3 o'clock. So we have like 33, 34 minutes for discussion and question and answer. So I would like to have participant having question or answer or discussion rather, and just giving note for us or through whatever you may raise your hand or something to Professor Tanaka or Professor Sana. Please to do so. Okay, we might need somebody that triggering. Might be Dr. Suntoyo giving a breakthrough, giving question or what you call it, something that triggering some other thing, giving question and a discussion. The sound is not quite sure, but I'm sure that that is Ibu Sade.
For the first question, there is.
Can you mention your name, please?
Anastasia Aurelia, please talk to the mic.
Okay, time is yours, Bu Anastasia. It will be help if also you write in the chat. You might able to write on the chat because might be the sound is not quite clear, but it will be helped by having the written matters. Pak Budianto? Pak Budianto Antowirio? I hear Bu Anastasia, but they stopped already. Hello? Can you hear me? Professor Tanaka, can you hear me? it seems that the sound is not quite stable. I mean the Wi-Fi.
I can hear you, Professor Vidhi. I can hear you clearly.
Okay,
Yes.
so okay.
Me too. I can hear you.
So please, participant, it was notified Miss Anastasia. I believe that she is from Lampung or Institute Teknologi Sumatera or something, I believe. Or might be Dr. Budianto, Didit Budianto Ontowirio. Halo, Pak Budianto, monggo, silakan, please.
All right. Thank you. Thank you, Prof. Widi. Thank you very much.
Okay.
I like to raise the questions to Dr. Ahmad Sana related to the tsunami measurements. No, it's the tsunami warnings radar systems that's already installed in Oman. I think they have 10 units. How do you compare the data from coastal wave as from the ADCPs, your ADCPs, compared to their measurement from the MKG, not the MKG, the meteorological agencies in Oman?
Unfortunately, I haven't seen that data as yet. These measurements we have done ourselves, so I haven't actually seen those measurements if they have done. You know, the most of the troubles in here is the data sharing, which is very difficult among the government departments. Mostly the people in the university, they are very open to share the data, but the government agencies, normally they are very possessive of the data. You might have known this fact for this region, you know. If you want to get some data, it is almost impossible. But if you, I can communicate with you. If you please let me know if you have some connection with that, we can work together to find that data and do some study. Definitely.
I would do that. I would do that.
Okay.
Please. Thank
So,
you very much.
Pak Didit, I think Pak Suntoyo will bridge because Professor Sana was friend with Professor Suntoyo in Tohoku.
Of course.
Will be able to bridge with you, you know.
All right.
Of course.
Okay. And might be direct to Professor Tanaka as well.
Yes.
Nice.
Okay. Thank you very much, Pak Budianto. Pak Budianto Ontowirio was in the Ministry of Research and Technology under BPPT, but now is moving to university.
Yes.
He is part of
Very
the
nice.
research in university.
Oh, which university?
Bakri.
Bakri, you know, is Bakri is the businessman.
Oh, businessman.
Businessman. I said, say.
Hello. So,
long time to not see you.
very nice salary.
Okay, it's good. And I mean, Professor Tanaka, Prof. Sana, and Pak Didit then is connecting again, you know. Is there any other participant that would like to have question to Prof. Tanaka or Prof. Sana, please? We still have time. Pak Suntoyo, you might be able to trigger question or something. Yeah.
I have a question.
Oh, okay, please, Pak Daniel. Prof.
Yeah.
Daniel, please. Yes.
Yes. I have a question to Professor Tanaka.
Yes.
Is a rougher seabed will make a tsunami less destructive?
Pardon? I cannot hear you well.
If is a rougher seabed
Lava.
will make tsunami less destructive?
Rough.
Lava. With a rough bottom, right? You mean?
Yeah, it's rough bottom will make tsunami less destructive? Yeah.
You mean from my study? What do you mean?
There is Prof. Tanaka, if
Yes.
might be help. If the material, the bed material coarser,
Yes.
that mean more resistant, you know.
More tsunami energy reduction.
Yes.
Yes. There's a physical process that the energy dissipation.
Okay. Okay. Is that satisfying you, Prof. Daniel? Okay. Prof. Alvaro, do you have any question?
Yeah, Pak. Thank you, Prof. Tanaka.
Yes.
Good morning, everybody.
Morning.
No, I do not have any question.
Okay. Do you want to say something? It has been long, you know. I didn't see you.
Yeah, I'm very glad to see you again. Unfortunately, at a very long distance. Good morning, everybody. I'm very happy to be participating in the ISOCEEN again, and I look forward to give my presentation soon.
Yeah, and we will be glad if you are coming to Indonesia as well.
Oh, I can't wait to go back. I really miss Surabaya and miss you all.
I see. Yeah, we are happy to have you. You know. Okay, is there anybody raising hand or something? Please. Student, mungkin mahasiswa, silakan. If you need translator, I will translate.
Yes, I have question, Prof. Vijay.
Okay, please.
I have question to my beloved brother Amasana, Dr. Amasana. Yeah, long time no see you. Okay, how did you simulate some properties like water quality, sediment transport, and other things related with your study? What kind of your software modeling and other things? Thank you very much.
Thank you very much, Dr. Suntoyo. It has been a long time. Very nice to see you. It's actually, we are still working. I mean, the PhD student that I was talking about, she did some numerical modeling using Delft 3D. So that included only a part of the hydrodynamics. So she did some comparison with the velocity profiles, which was not included in this presentation. It is still, we are still working on it. Major part was measurements that we finished recently. So we are still working on the numerical model. But of course, like as you know, we are talking about a huge area, and we have to have a lot of concerns when we are going to do the numerical modeling. But at least we have the reference data now. We can set it up. Once the model is set up, I think it will be useful. But Delft 3D is what we currently are using.
Thank you, Pak Suntoyo, and thank you, Prof. Sana. Is there any
Thank you very
other?
much,
Please.
Doctor.
Pak Toto, please. Pak Toto Supriyo. Hello. Pak Toto is having question for Professor Tanaka. What was the time spent for sand speed development at Kitakami River mouth after eroded by tsunami? Can you catch up my reading? So Toto Supriyo was asking to Prof. Tanaka, what was the time spent sand speed development at Kitamani River river mouth after eroded by tsunami?
Time span.
Time span.
You know,
the time.
Yeah, we spend
duration.
we spend more than 10 years, but no recovery yet. So no one knows what will happen in future. But what I expected, it will take another 30 years for
recovery.
For recovery, right? So it takes a long time for recovery process, and yes.
Okay. Thank you, Prof. Tanaka and
Yes.
Pak Toto for your question. Please, even in Bahasa, you may write in the message or whatever. I can read that, or might be in English. You just pick up microphone and asking to Prof. Sana or Prof. Tanaka. Dr. Sadid, do you have any question?
Please, Bu Sade.
Halo, Bu Sade.
Yes, hello.
Please. Prof. Tanaka, Bu Sade is from Japan as well.
Oh, really? Oh.
Alumni.
Alumni, okay.
Yes, I'm graduated from Hiroshima University.
Yes.
Yes, so regarding the ocean research.
Yes.
So because my main research topic is regarding ocean energy.
Mm-hmm.
So I wonder how can the research about the sedimentation and boundary condition can fit in this topic. Yes, that's my question. Thank you.
Sorry, I couldn't understand well. So you wish to know how?
Yes, the role of this
role. Yes, role of what?
Of ocean. Boundary condition research.
Oh, boundary layer, not boundary condition.
Boundary area.
Yes. Okay. So, you know, the role of boundary layer is the how to say, for example, related to energy dissipation and also related to sediment movement, as I explained. Right. So for your topic related to wave energy, it might be to some extent related because of wave height decay due to friction.
Yes. I also think that when we apply like ocean current turbine, there will also interaction with the sea plasma. So there might be there's like interaction between the turbine and the sea bottom. So there will be a like erosion or something like that.
Erosion.
Yeah. It also connected to the boundary area research. Yeah. So because in Indonesia we are going to this is still in the plan to have ocean current turbine. So probably the research will be expand to the boundary area topic too. I think it's like it's not question, it's actually discussion on.
The sorry, internet connection is not so good, but I can guess that when you deal with the sea bottom morphology change, this kind of topic is very important because normally sediment transport rate and a resulting morphology change can be predicted using the shear stress acting on the bottom. So the precise evaluation of bottom is very, very important for sediment and also morphology change.
Thank you very much.
Thank you.
Okay, thank you, Bu Sade. No further elaboration. Okay. Hello, we still have couple minutes.
Still have question, I think.
Who?
Pak Toto.
Pak Toto again? Okay.
Yes.
Okay, please, Pak Toto, can you speak up?
No, Pak Purwanto.
Pak Purwanto.
Purwanto.
Oke, silakan.
Please, Pak Purwanto. Pak Purwanto.
Okay.
Yeah,
so this question is for me. Yes, thank you very much for asking this question. But we have nearby in our area, we have low dissolved oxygen zone. They call it oxygen minimum zone. Sometimes that zone actually penetrates into Al-Batina area, which is we call as Sea of Oman. And because of that, in some of the places, the dissolved oxygen becomes very low. Of course, as I mentioned, this is a seasonal variation, and what we have measured, we can observe only within that couple of months time that what is happening there. We haven't measured for the whole year to cover at least 1 year of measurements to see at one location that what is happening there. That location is only one place, which is near the oil refinery. So only for that location I can say that. But the only thing that we are gathering from that is the lower values of dissolved oxygen means it is a critical situation for the marine life. So further measurements, monitoring, or further actions in order to improve the water quality has to be considered. So as I said, we are not sure 100% what is the reason for that, so yeah, so it's like, of course, I'm sorry, probably I couldn't answer your question 100% because I don't have 100% knowledge about the about the phenomena as yet.
Okay. You might having conversation by having Pak Suntoyo facilitation or by sharing your cell phone number or whatever. This fora helping bridging all over the world researcher to bring knowledge as well as hopefully peaceful. So we still have 20 minutes. So would anybody would like to have question or discussion, please raise your hand or send me a message or whatever. Hello.
Prof. Vidi,
Yeah,
I have another question for
Please.
Professor Ahmad Sana.
please do.
According to your findings, the water quality and coastal parameters along Oman, is it proper or is it supporting the aquaculture industry in Oman? That is my first question. The second question is, how is Oman dependent upon food resources from the sea? Okay, thank you. Thank you.
Both of them are very good questions. Both of them very good questions. Thank you very much for asking. First of all, as I mentioned that, of course, there are some problems, environmental problems related to the water quality. But in general, most of the indicators are good. So marine life is like at some of the locations during some of the time of the year, it is of course under stress because of the low values of dissolved oxygen. But in general, for the other parameters, the most of the places are fine as compared to the international standards. So that there is not like a serious problem as yet. Second question, of course, historically for food, the whole of Oman was dependent and still is dependent on the aquaculture or the marine life. A lot of people, a lot of jobs are related to this sector as well. From economic point of view, I don't know what is the which is the rank of the aquaculture industry in Oman. Of course, the top rank is for oil and gas, for the source of money, or source of jobs as well. But probably second is the aquaculture or marine life, related to which most of the people, they have food as well as the jobs, employment, I mean. And also they are putting in some more emphasis on this, because as you know, the oil and gas, they are depleting, the resources are depleting, and also the international community, they are depending now, trying to depend less and less on the fossil fuels. So oil prices are going down and all those things are there. So they are trying to create more, put more emphasis on this industry of aquaculture.
Thank you, Prof. Sana.
Thank you very much.
Okay, thank you. Is there any other, please? Prof. Sana, this is not question, but just confirmation. You will be having, you will be visiting Surabaya in December, right?
If there is a conference, I haven't submitted a paper yet.
Okay. Okay.
But I would like to definitely. I would like to submit definitely. If there is a conference, I would submit the paper.
Yeah, I think it's opportunity to have partnership, even though we have challenge with
Yeah,
pandemic, you know.
definitely.
So
I
we
would
have to
love to.
overcome the situation.
Definitely, I would love to.
Yeah.
That
And
would be very nice.
special request as well for Professor Tanaka. This is the last year of serving to the government, right? So you will be free and flying to Surabaya.
Next year, you will organize.
No, this year. Is
This
that your
year?
last year serving to the government of Japan?
Ah, no. 1.5 years more.
Okay, okay.
Yeah, but as you know, our new prime minister visited your country.
Yeah, they just visited Indonesia.
Yeah, very recently. And
Yeah.
I really wish too.
Okay. So it's good, but we are comfortable with last prime minister, you know.
Ah, yes, but new prime minister also. Oh, he has a
Okay.
yeah. So
I didn't know
leadership.
him, but the last prime minister we know him very well.
Shinzo Abe. Right?
Yes, yes.
Yeah, because a long time his the prime ministership. Yes.
Yeah, but traditionally we have very close relationship with Japan, you know.
Yes, I know.
Yeah, with Japan, with United States, I think we are having. It's not ally, but we are partnership, as well as Europe, you know.
Yes.
But now a bit changing. The world a bit changing now, so we have to figure out. By the way, is there any question? We still have 10 minutes or so. Otherwise, then I would like to have Professor Tanaka as well as Professor Sana.
Excuse me, Prof. Widi.
Okay.
There is a question from Mr. Toto Supriyo. Is there any water quality problem, for example, seawater intrusion, at Kitakami River Mosque during development design speed development? From Toto Supriyo to Prof. Tanaka of Tohoku University.
About salinity intrusion.
Is there any water quality problem?
Yes, serious problem.
For example, seawater intrusion at Kitakami River Mosque during the sand speed development.
Even now, serious problem, right? As compared with the previous situation, salinity concentration is much higher, right? So even in the river mouth, its environment is like seawater. So, but in the past, because of the development of sand speed, right, the very nice brackish water was there in the estuary area. But now the estuary, it is not estuary, it's like a seawater. So like that, the late morphology recovery causes a water quality problem.
Okay, that be it, Pooh. Okay, thank you, Prof. Tanaka.
Yes.
Okay, we will be having 10 minutes, so I would like to have Prof. Tanaka and Prof. Sana giving your last word, you know. Please having each 5 minutes or so, giving what next opportunity or whatever you would like to mention. Please, Prof. Tanaka and then Prof. Sana.
So first of all, I'd like to express my grateful thanks to you all for this kind of a nice opportunity to make a presentation and also to discuss with you. And as I talk to you, I have 1.5 years more in my university, and yeah, because only 1.5 years, I cannot accept any more students from Indonesia, right? But so it's a very pity, but still I'm very active for research activities. So it is my great pleasure and my strong wish to keep a good relationship with the Indonesian people, especially with my past student. And yeah, although no educational activity anymore, but I still wish to keep a good relationship in research activity. Thank you very much.
Okay, thank you, Prof. Sana. Prof. Sana?
I would like to thank also to all the participants for listening to me. Of course, biggest thanks to the organizers of this international seminar. It is an honor to talk to you. We have, of course, you yourself, you are a big institute and you have like master's or PhD degrees as well, education. But in our case, also in Oman, in our university, we have some scholarships, although it is not as high as in Japan, but we have like a kind of modest scholarship for PhD or master's studies. So if some of the students, they want to apply, please encourage them to apply for that. Also for the research collaboration, I would like to invite you if you would like to have some research collaboration with me. I have been working under supervision of Professor Tanaka, and actually the topic that he has presented today is very interesting. I am very interested in that as well. Of course, I will talk to Professor Tanaka privately about that, but like for all the other participants, if they are interested to do some research related to Oman, the work that I have done, that would be great. I would welcome that. And also, I think my email will be probably shared with all the participants, hopefully. So anybody can contact me. I would try to reply to you as soon as I get your email. I really love to have collaborative work with all the people who are interested. Thank you very much.
Thank you very much, Professor Sana, as well as Professor Tanaka. I think we are about closing in this session. So we thank you all for this participation, discussion, as well as communication and future possibility, of course, because Prof. Sana mentioning about the possibility of having scholarship to Oman, and this is some other potential collaboration as well, if there will be kind of research, joint research or whatever. So I apologize if the case anything was happening during my leading the session, and hopefully that will be all of us safe during the COVID pandemic, and we'll be having opportunity to see each other in the near future. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much.
Thank you.
Thank you. Thank you. Thank you.
Professor Hitoshi Tanaka and Associate Professor Ahmad Sana. It was a thorough and relevant discussion. Thank you so much for sharing. We are now entering break time. This break duration will take about 20 minutes, and we will continue to the second session at 3:15 p.m. Surabaya time. Welcome back, ladies and gentlemen. Now we will enter the second session speech from our keynote speakers. The first speech will be delivered by Associate Professor Alvaro Semedo, PhD, from IHE Delft, Netherlands. Then, the second speech will be delivered by Associate Professor Technologist Dr. Muhammad Faris Hamidi from College of Engineering, Qatar University. This session will be guided by Professor IR Daniel M. Rashid, PhD as moderator. To Professor Daniel M. Rashid, the stage is now all yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen, colleagues and friends. I'm happy to chair this second keynote speech session. We are going to have Professor Alvaro Semedo from IHE, the Netherlands, and Professor Faris Hamidi from the College of Engineering, Qatar University. The first speech delivered by Professor Semedo is the Era 5 Reanalysis, a new seamless Europe Center for middle range wave weather forecast and an atmospheric climate data set. It's going to be a very a comprehensive presentation. Professor Semedo will talk about this capability developed by the European communities and actually having a capability to forecast weather by integrating the atmospheric data, the land surface, and the wave data in an integrated manner. ERA 5 is a replacement for the ERA interim. And this latest development has managed to collect a record of data since 1950 up to now, and by combining it as a integrated forecasting system, the European community will be able to provide better and more accurate data. It also compare the in situ measurement, and it provides a good fit, at least for the wave height of the data in situ. So it's a really a massive effort, and we're going to have a more detailed presentation by Professor Semedo. You have 20-25 minutes to present your paper, Professor Semedo. The time is yours now, please.
Hello, good morning. Assalamu alaikum. I hope you, just 1 second. I started actually from the last slide, so I'm going to make it correct now. Thank you very much. It is a great pleasure to participate in ISOCEEN once again. Unfortunately, we are all apart, and unfortunately, I'm not in Surabaya as I would like to be. I got used to go to Surabaya on a regular basis, so I really miss going to Indonesia, and I miss all my colleagues from ITS. Nevertheless, it's again a pleasure to participate in ISOCEEN. So I will talk about the ERA 5 reanalysis. I will explain a little bit what a reanalysis is and how we can use it for climate studies. I will focus mostly on the wave part of the ERA 5 reanalysis. Nevertheless, I will talk a little bit about the atmosphere also. So I will go around this 4 questions. So I will explain what a reanalysis is and what is the difference between a reanalysis and a hindcast. and why do we use reanalysis for climate studies, and why reanalysis are actually important to monitor climate. And then I will specifically talk about the ERA5 reanalysis. The ERA5 reanalysis is produced by the ECMWS, the European Center for Middle Range Weather Forecast. The ECMWS is located in Reading. I don't work specifically or physically at the European Center, but I have a lot of collaborations, and I do a lot of work, a lot of research with this center. The ECMWF is the center that provides weather forecasts for the European countries. It is not only an European or a European Union center, it is an European or a pan-European center. There are countries that are not part of the European Union, but they are actually part of the European Center, like Turkey, for example. So climate, we define climate as average weather. So we have weather every day, and then we define climate by averaging different, usually atmospheric parameters. We can also talk about wave climate, which is something that we are more connected here in the ISOCEEN community, since we're talking about ocean. So we can also talk about wave climate if we add average sea state characteristics, and the sea state is usually defined by different wave parameters. So weather, in a nutshell, is a short-term state of the atmosphere or sea state. It varies very fast from time to time, from one location to the other. It always includes time and location, of course, and as I mentioned, it can change in a few minutes or hours. The climate is a bit different, so it's a short-term pattern of weather, actually a long-term pattern of weather, and by long-term I mean 30 years or more. So if we want to define the climate of a specific place, usually we gather data at least for 30 years. It is the average weather or sea state, as I mentioned before, over a long period at one specific place. And climate doesn't vary as much as weather, of course. The climate fluctuations are way slower or lower than weather, fortunately. But how do we monitor climate? So we need to monitor climate, especially in these days, because we are facing what we call climate change. So when we talk about climate change, it means that we can monitor climate, and we can measure and assess these changes. So we are worried in assessing changes in the present climate, but we are also worried in assessing changes or future changes. So we literally have two blocks or two areas or time slices where we assess climate change. Present climate, and by doing that we have to monitor climate, and then future climate changes, what we call climate change projections. Last year I spoke about climate change in the future. In this talk I will focus on present climate or recent past climate. So how do we monitor the recent or recent past or present climate? Well, we can use observation, so we can observe the climate on a regular basis by measuring weather and sea state parameters, or we can also use modeling data sets. Well, if we use observations, which is the most logical way to do it, so we just observe climate, or we observe weather parameters like wind speed, relative humidity, precipitation, pressure, whatever parameters we can imagine that define the weather. So by collecting these observations, we can monitor climate. This is the way that makes more sense. Nevertheless, observations have problems. They are, of course, very accurate, especially if we collect them in situ, like in this picture here, with a ground weather station. But observations are sparse. They are not homogeneous spatially. In some countries, there are more than others. Typically, there are more observations in the northern hemisphere than in the southern hemisphere. Developed countries typically collect more observations than developing or poor countries. So observations are sparse. They can be irregular in time, in the sense that instruments break. Sometimes they are subject to the elements or storms and they break, or they have to be maintained. So the time series is most of the times not constant. So there are some irregularities. And then they vary from one instrument to the other. We have different instruments. Some instruments have a different sampling frequency or time resolution, as it's sometimes called. Definitely observations have problems, and they need a lot of data processing. And they are not homogeneous in time. As I just mentioned, they vary from one instrument from the other. Each country has different observation standards. So there's definitely some problem. There are definitely some problems with observations. Another way to monitor climate, as I mentioned before, is by using modeling data sets. And modeling data sets, since they are just a product of a computer set of a software or a set of computer lines, so model outputs are way more regular, because we can determine when we have the output, both spatially and on a time scale. But sometimes they are not always homogeneous, as I will mention soon. Nevertheless, so of course, observations, as I mentioned before, is the ideal way to observe climate and to monitor climate. Model data sets are a good solution to cover, for example, areas where we don't have observations. But still, there are also some problems, and sometimes we have to combine both of them. So if modeling data sets are a good solution to monitor climate, and since we periodically forecast weather and sea state, why don't you use wave forecasting data for climate studies? So when we forecast the weather, we usually forecast, and by weather I mean atmospheric weather, but also wave forecasting or sea state forecasting. So sometimes if I mention just weather, I will mention both the atmosphere and the sea state. So when we forecast the weather and the sea state, we usually do it for a relatively short period, maximum 2 weeks. And these 2 weeks, we call it medium range forecast. And when we forecast the weather and the sea state, we have systematic errors, and the longer or the older the forecast, and by older I mean when we are more apart from the hour or the date where the forecasts were generated, so we have systematic errors. So that's what I see here, what we see here in this plot. So in red we have let's call the true state of the atmosphere. And then in blue, we have the forecasts. And as we move in time from left to right, we have what are called forecast errors. So systematically, we correct the forecast error. So we produce a forecast from time 0 to 2 weeks. And then let's say 1 day after, we correct the forecasting error by blending the model output with observations. And then we generate another forecast. So to this correction of the forecast error, or to the blending of model output and observations, we call analysis. And analysis is the true state, and true quote unquote, is the true state of the atmosphere of the sea state. So it is the initial state of the atmosphere and sea state that we use for the forecasting, for the next forecasting period. So weather and wave forecasting, and why do we need this true initial state? Because weather and wave forecasting are an initial value problem. So we need the initial value. So we actually solve a differential equation based on initial state. So we need the initial state to assess the state on time 1, time 2, time 3, so on and so forth. So this analysis is the closest we have. It is, of course, not true, the true state of the atmosphere. That's why I had there between quotation. So it is not the true state, but it is the closest we have of the true state of the atmosphere. So it is a very nice product. It's extremely accurate. It is a very nice and interesting product to use for climate studies. So why not using the store? So when a weather center produces a weather forecast, everything is stored, all that data is stored forever. And of course, the analysis and the forecasting, the different forecasting outputs are stored. So why don't we store the analysis, which is the closest we have to the true state of the atmosphere or the sea state, to monitor the climate? So if we do that for since we store it, if we do that for a long enough period, then we have our problem of monitoring climate using a model data set solved. Nevertheless, this is not the solution. It is not the solution because these analysis outputs are not homogeneous. As you can imagine, throughout time, models, and by model I mean numerical weather prediction or wave models, or wave forecasting models, the models evolve in time. So we are constantly producing new science. So we are constantly improving the models, improving the resolution of the models, because we get new computer facilities. So we are constantly changing our model. And because we change our model, we produce inhomogeneity. So the data is not exactly homogeneous. So as I said, we can store all the analysis, which is very close to reality. But since these analyses were produced by different model versions and different resolutions, the data is not homogeneous. So what we have here in this time series, and we go left to right in time. So we have, for example, an output of a specific or a general parameter A, and we have the model output from model version 1, 2, and 3. And the outputs vary. They vary slightly. In fact, the differences might not be that much. But when we're looking at climate, we cannot work with these inhomogeneities, because look, if we are trying to assess, for example, a trend, which is probably the most interesting or the most interesting output that we want from a data from climate data. If we're looking at a trend and we would use this three versions of a general model, we cannot assess the trend. We would get it wrong. And trends are very important in climate monitoring. We want to know if the temperature is increasing or decreasing, if the wave height is increasing or decreasing, so on and so forth. So inhomogeneous data sets cannot be used for climate studies. So the stored analysis cannot be used for climate studies. So the solution to this problem is, instead of using reanalysis, is using reanalysis. So we produce a reanalysis by rerunning the analysis procedure, but now using only one model version. So we go back in time using all the stored observations that are assimilated periodically to produce analysis, but we go back in time using the same model version, usually a state-of-the-art present model version. So this is how we produce homogeneous climate data sets, like, for example, the ERA 5 that I will talk about in a while. So the aim of reanalysis is to overcome model and data simulation schemes inhomogeneities. So we are now using the same data simulation scheme and the same model. We use the state-of-the-art system using the same model version, data simulation scheme, and these are used to repeat the analysis procedures in the past. The reanalysis goes back in time as far as we have data available. Usually we start in mid-20th century. A complete description of the atmosphere and sea state over a very long period of time is free of inhomogeneities, is now obtained. And the reanalysis allows for a close monitoring of the Earth system, including where direct observations are sparse or don't exist. And this is a very key element. So observations are good to monitor climate. By using modeling, we can, for example, generate data sets in the middle of the Southern Ocean, for example, where we have basically no observations. So this is a very interesting solution. So now what we see here is, by using reanalysis, we will not have model version generated inhomogeneous. So we have an homogeneous data set, and we can now look at, for example, trends. And now going back specifically to ERA 5 reanalysis, which is the latest and more modern reanalysis ever produced worldwide. The European Centre has a long history of producing reanalysis since late 1990s. So the first reanalysis was the ERA 15, only for 15 years, 1979 to 2003. So it was a very short period, a very coarse resolution, 2 degrees. After that, the ERA 40 was produced for a period longer than 40 years, already with an increase in resolution, 1.5 degree. Soon after, in the late or close to 2010, ERA interim was produced with an increase in resolution, 80 kilometers for the atmosphere and 1 degree resolution for the wave parts. And the time span was from 1979 until 2019. And then ERA Clean was produced in between. The ERA Clean is a relatively different product, is a much longer product that covers the entire 20th century at a 1 degree resolution, but only with a daily output, so one output per day. And the ERA 5 is, as I mentioned before, the latest reanalysis produced by the European Centre, with a very increased resolution, 31 kilometers for the atmosphere and 40 kilometers for the waves, and it spans from 1950 until present time. So it's produced with more or less 2 weeks delay from present time. So ERA 5 is part of the Copernicus Climate Change Service. It has atmospheric and wave parameters, replaces ERA interim, as I mentioned before. It benefits from 10 years of model development from 2006 and 2016, improved model developments in the atmosphere and in the wave model also. It has a much higher resolution, as I mentioned before, and it has a much more and better input input observation for the reanalysis procedure. It has an hourly output. It has a much higher time resolution. ERA interim had, for example, 6 hours resolution, and it has a longer time span back in time. Instead of 1979 from ERA interim, it now goes back to 1950. So we have presently roughly 70 years of data. So here you have an example of the improvement of the improvement that ERA 5 brings, for example, in resolving a tropical storm. This is the east coast of the United States, and we have tropical storm Florence. And on the left-hand side, you have ERA 5 output, and on the right-hand side, you have ERA interim. So there is a significant improvement, as you can imagine. And this brings us to the performance of ERA 5 compared to ERA interim. We'll get there, but along with ERA 5, I've been talking about atmospheric and wave outputs from ERA 5, but now I will concentrate mostly on the wave, on the ERA 5 wave part. Along with ERA 5, we produced what we call the ERA 5 Hindcast. So the difference between a
Excuse me? You
5
have
minutes?
5 minutes left.
Yeah,
5 minutes.
yeah, I will be in time. Thank you very much, Professor Daniel. So we produced what we called the ERA 5 Hindcast. A Hindcast is a rerun of a wave model without data simulation. So this is the difference between a Hindcast and reanalysis. We used ERA 5 winds. We changed the wave model by using a more accurate wind input and wave dissipation parameterization. So we changed the wave model. We improved the resolution. We went from 40 kilometers to 14 kilometers. As I mentioned before, we used ERA 5 winds that were interpolated from 31 kilometers resolution to 14 kilometers, and we didn't use data simulation. That's why we call it Hindcast. So this is the most, this is a global product at 14 kilometer resolution. So it's a very high resolution for a global product. And this was an experiment, so we had really good hopes on this product, and the hopes were proven true. So how does ERA 5 waves and ERA 5 Hindcast waves compare to ERA interim, and how do they compare to buoy and remote sensing observation? So basically, we try to assess the skills of these three products: ERA 5 Hindcast, and ERA interim. So what is the added value of ERA 5 and also of the ERA 5 Hindcast? So we have here on this map a set of in situ measurements, mostly buoy measurement, but also wave measurements from oil platforms, for example. So we have more than 1,000 in situ measurements, and we also use remote sensing measurements from radar altimetry from TOPEX, Poseidon, and GeoSat missions. This is the most comprehensive in situ buoy data set ever put together. So we have a huge collection of buoy data set that we use to compare or to validate or to assess the skills of these three products. And what we have here are the significant wave height and the 10 meters winds ERA 5 output versus buoy. So we have the root mean square error. So as you can see, and we have waves on the top and winds below. As you can see, we are all on the green side. So we have very low root mean square error. And remember, this is just ERA 5. And then what we have here is now a comparison between ERA 5 Hindcast, and ERA interim. And we have a quantile plots in three different areas: the tropical Pacific, the east extratropical southern Indian Ocean, and then the Baltic Sea, a very enclosed marginal sea. And in green and blue, we have the ERA 5 and the ERA 5 Hindcast, and in red, we have the ERA interims. And as you can see, the ERA 5 and ERA 5 Hindcast significant wave heights are way better resolved by the two new products that compared to ERA interim and assessed by comparison with in situ measurements. And we went back to the three data sets, and we compared what we called we compare the scatter index, and there's also a considerable gain on the two new products. And the scatter index are the lines in blue and green. So the scatter index, especially in the Indian Ocean and in the Baltic Sea, are way lower than the scatter index in the area interim. So there is an added value. The difference in the tropical Pacific is not as striking as in the other areas, but nevertheless there is also a gain. And what we have here are what we call the intra-annual variability. So basically we are assessing how the product resolves the seasonality. And we have in blue and green, and then in very short staggered line, we have the in situ observations. And the area interim, in ERA 5 and ERA 5 and CAST, we have a way better comparison with the in situ measurements compared to area interim. So there is again a significant added value here. And then we have here the Taylor diagrams. These are a bit hard to measure, but basically what we have here on the vertical axis is the standard deviation, and then what we have in the horizontal axis is the correlation coefficient. So when we have, if we have comparisons closer to that one value on the left, on the right hand side, that would be a perfect assessment. If we go, for example, and we have different colors and different squares and different dots, if we concentrate on the black dot, that's the global assessment, we can see that both ERA 5 on the left hand side corner and on the right hand side corner, the ERA 5 and CAST, but in both these products, we have the black dot closer to 1 when compared to area interim. So there is again a significant value, a significant added value. If we look at the separated areas, regional areas, we can also see this added value. And I think this is the last plot. So what we have here are biases. So, but in this case, we compared the three products, area interim, ERA 5 and ERA 5 and CAST, with satellite altimetry. With satellite altimetry, you can measure significant wave heights, and we computed the bias for the three products. And if you look at the lower panel, that's the bias for area interim, and you can see that it is slightly higher when compared to the mid panel, which is the ERA 5 hindcast bias, and compared to the upper panel, which is the ERA 5 bias. So there is, at a global scale, here we can see the added value of the ERA 5 and the ERA 5 hindcast compared to remote sensing significant wave height measurements. So in summary, I will conclude in summary. You allow me just 10 seconds more, Professor Daniel?
Yes, please continue.
Yeah. So, there is a better agreement in surface wind speeds compared to in situ observations for ERA 5 compared to area interim. The significant wave height agreement with in situ observations has been improved for ERA 5 and ERA 5 and CAST, again compared to area interim. HS inter-annual variability, how the model defines seasons, has improved also for ERA 5 and ERA 5 and CAST, again compared to area interim. The global biases obtained from comparisons with satellite altimetry observations has been reduced for ERA 5 and ERA 5 hindcast compared to area interim, and the ERA 5 hindcast, remember at a much higher resolution, is in general better than the ERA 5 reanalysis. And the European Center was very much interested because they put a lot of money and a lot of effort in producing this new reanalysis. So they were interested in assessing the added value, in quantifying the added value. And this is what we did at IHE together with colleagues from the European Center. So we quantified the added value of the ERA 5 and ERA 5 uncast, and this is roughly what I have just showed you here. So thank you very much for your attention. Terima kasih, and I'm more than available for questions about this presentation.
Thank you very much indeed, Prof. Samedo. It's a very comprehensive presentation, and I think we have to congratulate for your efforts to develop the capability of having a better forecasting system. Thank you very much indeed. Ladies and gentlemen, we would like to have now, for the second session, a presentation by Professor Muhammad Faris Hamidi from the College of Engineering, Qatar University. Professor Hamidi will be talking about globalizing national resilience agenda via transdisciplinary approach for having a global knowledge for local action. Yeah, it's going to be very interesting topic, and we are happy that we have just listened to climate presentation, and I believe that one of the issues that will be addressed by Professor Hamidi is also about climate change. Please, time is yours, Professor Hamidi.
Bismillahirrahmanirrahim. Assalamualaikum. I hope everyone hear me well.
Waalaikumsalam.
Yeah. Terima kasih. Thank you to Bapak Professor Engineer Dr. Daniel M. Rashid. All right. Let me take a little bit of time so that I can stay on time. All right. So I try to finish this within 20-25 minutes, as being mentioned by Professor Moderator. So I will try to share with some of our initial effort in terms of research in Qatar, where I am now. I'm with Qatar University. I joined this university since September last year, so I'm quite new here, just only about 1 year. And of course, it is quite interesting that within this short period of time, I think this is not only to Qatar, but I think it is a global concern. We are fully aware about what's happening due to the pandemic, COVID-19. And of course, there are a few occurrences and incidents around the world that may have shocked us as a global community. I'm referring to concerns around how resilient a nation need to be or it can be. So with that in mind, so this is my presentation today. It is a little bit, I would use the word generic, because I try to demonstrate this resilience agenda in a more global picture, or the big picture. But I also try to bring in dimensions so that, as highlighted again, of course, climate change issues are one of the biggest agenda if we try to think about resiliency of a country or of a nation or even of a city. But again, this is trying to bring everyone, every stakeholders, every disciplines, every research areas in particular, into one big framework. Okay, let's see some of the outlines. So as you can see here, I'm not too sure some of the keywords that you see today are not new, but of course it is good for us to revisit and try to share some of the common definitions so that everyone is on the same page in terms of context and also how we approach these particular keywords. And I will also try to bring on board or revisit the idea of globalization, because we realize that, for example, for the past 8-10 months, due to the pandemic COVID-19, many countries or the government of that particular country try to, lack of transparency, for example. Right, but then again, we understand how the world we live today operates. Obviously, there are many areas where we always, not to say we like to, but there are always a reference point in terms of the establishment of United Nations. And of course, if we talk in the area of disaster risk and reduction, we can always go to UN DRR, for example. So this is some of the idea about globalization and how it will help in terms of pushing forward the agenda of resilience at the local level or context. And then again, another revisit about transdisciplinary, because I'm in a college of engineering. When I was at University Technology Petronas in Malaysia, early as 2010, at the university level, we have started to work beyond our very own discipline, or we also say beyond our own silos, because like it or not, due to the nature of the concerns or of the issues that we are facing, a lot more of them, I would say majority of them, needs or can only be solved with transdisciplinary approach. So that is the reason why for national resilience agenda, there is no single input or there is no single approach to it. As I've mentioned earlier on, we need to bring everyone on board, all the stakeholders and all the disciplines that we have, working together, collaborate, and therefore this is the transdisciplinary approach that we are talking about. And then I have a few examples, because since early this year, I have been working with a few circles of friends working on disaster risk and reduction. Of course, Malaysia is always there. I'm from Malaysia. New Zealand, some colleagues from New Zealand. I think this is an organization which is under the government called NZAC Resilience. So we are working closely with them. We have a few colleagues at Nanyang Technological University, for example, in Singapore. And of course, over here, I'm in College of Engineering in Qatar, but we are also working with our friends in Medical Health College, for example. With business and environmental sciences college, for example. So it is very clear that we now have to work and collaborate beyond our own disciplines and across all what we call in a more broader spectrum in that sense. All right, so, and of course, it is always good to ask what is a national resilience, for example. All right, so if you look here, as I mentioned, we are now, I can use this acronym in a VUCA situation, VUCA, that refers to volatility. All right, so when, for example, it is quite timely, pandemic COVID-19 is one very easy reference to what is happening today globally. So it is just a very small virus, very tiny microorganism, but it is so volatile, it is so contagious. And if I got it correctly, based on World Health Organization report, it is now affected around, if I remember it correctly, 42 million people all over the world. And it has killed about 10% of them as well. All right. And then it is very uncertain. All right. Uncertain in terms of previously, we may be saying from risk management point of view, we know the knowns and we know the unknowns. But today, in terms of uncertainty, we also do not know the unknown. It can be very new things emerging, just out of the blue. So this is uncertainty in VUCA. It is also complex. And of course, there are always a gray area in terms of referring to the word ambiguity. So again, COVID-19 is the best example for this, but it is not only about health concerns. It can be anything related to natural hazards, disaster. It can be man-made, it can be natural in that sense. It can also be about cyber attack and things like that. All right, so with this in mind, so sustainability alone is not sufficient. As you can see here, sustainability is the practice of reducing or eliminating environmental impact. So we are talking about how big or how strong is the impact, but it is also about if this impact occurs, how this will affect or improve our quality of life, referring to the socio-economic context for any particular community. But on the other hand, although it looks like two dichotomy in terms of sustainability and resiliency, but to me, it should be complementing each other, where resilience is the practice of designing things. So when we say designing things, it is actually something we as a mankind can work together and ensure putting resilience in the right place, in the right order, in order to endure physical, social, and economic shocks and stresses. So you will look at the triple bottom line in terms of sustainable development, for example, the social aspect, the economic, and the environmental aspect is there. And in resilience, we also focus on social and economic, and of course, the physical aspects refers to the environment. And if you look at this, I think I can doodle something or use highlighter. Okay, so in the context of time, as we move into this x-axis, if the system is not resilient, so this is what happened. You will take longer time to absorb the shock, and then you will have to implement something or some system to recover, and then most likely you will need to adapt to the new changes that occur due to this disturbance or due to this shock. But if you have a resilient system in place, so the recovery will be quicker and most likely you will become better off. All right, so over here also in relations to time, we are talking about how fast we can bounce and recover and then quickly adapt to the new ecosystem, for example, because of the shock disturbance that are taking place. Again, if I don't have to elaborate, COVID-19 pandemic is the best example to showcase this. There are a huge contrast between how country like New Zealand, for example, responds to this. How country like Singapore or even Malaysia, we are doing pretty good, I would say. But there are also instances and examples, country like Italy, when it began in March all the way to June. United States is still not in a good shape. And of course, it is worsening now in Brazil, for example. This is mainly because resilient system, in particular referring to the public health system in that particular country, is not that resilient, I would say. Then again, as I've highlighted, previously we focused so much on risk management, as you can see here, but then again, knowing that there are unknowns, there are things that we do not know and we do not know what they are. All right, so we need to quickly bring on the resilient systems. And I think, although this could be at the personal level, but most of the people, experts that are working with, they agree this has to become a national agenda. It also means that not only the government, but also all the key stakeholders in any particular country needs to come together and come out with this national agenda of providing resilience for that country. So my point here is that if we can achieve this, only we can ensure the sustainability of our future generation, so to speak. So let's move forward to look at some of the diagrams. I would say that some of the early works related to resilience is about City Resilience Index. I think this is sponsored by Rockefeller Group in 2014, and Arup is the key members of this, I would say, a team working on City Resilience Index. I think it involves around 50 cities all over the world. I think Kuala Lumpur is there, Jakarta, of course, is there. But the good thing about this diagram is to show you where the state of resilience with respect to the three core dimensions to protect people's well-being. So again, as I have mentioned, is about economic well-being, physical well-being, and social well-being. If there is impact, then of course, you know, we have to think about achieving this particular part. All right, so that is where if we have resilient system in place, I believe whatever shocks that occur, so the country will not be seriously affected, and therefore things can go back to normal as this is the whole idea of putting resilience into place. And we agree that it is a very complex system. Looking at climate change impact is one of them, but again, if you break down what climate change can do to not only to our environment, to our only planet Earth, and also to our civilization, for example. But here, if you break it down, we also can talk about global warming. We can talk about sea level rise. We can talk about all these what we call chloron, all these occurrences in the oceans. All right, that will affect all the sea reefs and things like that. So therefore, but when you look in the bigger picture, then you realize it is also about, I've mentioned about health and well-being, economy and society. It's also about leaderships and strategy, right? So people who are holding, I would say, formal offices, not only in the government, but also in the ministries, for example, must know why this resilience is important. And of course, if we go to the other physical aspect, if we talk about infrastructure and ecosystems, as you can see here, we basically can design things how to absorb and therefore recover and adapt to this resilience, shock, and disturbance. One of the things that we have learned together with our research team is about socio-technical. I will not be able to explain this, but as you can see here, I put the source here. So we work closely with Professor Zulfikar Amin, who is in Nanyang Technological University in Singapore. So it is a very complex system. And it not only involves the technical aspects, or if we can say the engineering system of whatever we have, but it also involves the social behavior, for example, right? So if you look here, and then also here, because it also, this whole ecosystems or spectrum will determine how best we can come out with the resilience system that we want to put in place. There will be an example when I showcase you the Singapore example. Let's move forward. And then I bring forward the idea of localization, because although it looks like more things to work on at the national level, but then again, there are a lot of things that we can learn from our friends and colleagues all over the world. So the idea of localization, again, is not new. As you know, Akio Morita, I studied in Japan together. I think Professor Suntoyo was also in Japan. And also the first keynote speaker was somebody, a professor from Japan. propose think globally, act locally, which refers to could be the first time the word local, a combination of global and local. So therefore, I use the word localization. It also refers to a technique of adapting farming ways or techniques to local conditions, which is known as docha kuka in Japanese. But then again, Akio Morita, we know what Sony's produce and sell to the consumers. So bring this into the business marketing strategy, for example. But in the context of what we are talking today, which is related to national resilience, we are referring to integrative relationship between global systems and local cultures, communities and societies in various contexts of political, social, and economic collaboration. It simply means that we can learn from each other. For example, again, I've been using this very many times. Pandemic COVID-19 is one good example about it. How countries that have troubles managing their public health in terms of absorbing this disturbance or shock, then they need help. They need advice from a country who has done this very well, or who has done or handled this issue or challenge very well. Globalization is also about acknowledgement that globalization can be in contradiction with local interests and needs. I think one good example in the early 60s or 70s, when the fast food chain McDonald's started to go out from where it is born, which is the United States. And then again, after a while, you realize from the idea of globalization, having like 5,000 branches all over the world, but now they also try to localize. For example, if you go to McDonald's in Kuala Lumpur, you can get a nasi lemak, for example, which you couldn't find nasi lemak if you go to a McDonald's in United States. So this is the idea of how localization can meet local interests and needs. I think I use the word here, compromise with the local needs. But more importantly is the third entity, which is the interplay between the global and the local that creates a third entity where assets of both global and local systems can be taken into account to compensate the weaknesses of the weaknesses can be both sides. It can be at the global assets, it can also be at the local assets. So local means bring on board a third entity that might solve the problems much or address the problems much better. And then quickly we look at transdisciplinary. I think looking at the audience today, I don't see, it is most of us aware about what is happening. So if, for example, for ETS, you have this ocean and coastal engineering that could be one interdisciplinary. But then if you look at the overall engineering ecosystem, you have multidisciplinary, and you may work together cross-disciplinary within that engineering entity. But then again, we must bring forward the idea of working together, collaborating, so that we can solve more complex, volatile, uncertain, and ambiguous problems and challenges. So the idea is moving towards this direction. All right, as you can see, interdisciplinary is integrating knowledge and methods from different disciplines using a real synthesis of approach. But then again, transdisciplinary is trying to create a unity of intellectual frameworks beyond the disciplinary perspective. So national resilience agenda to me has to achieve a level where transdisciplinary is applied, because if you look at the literature, more often than not you will realize that a lot of people, a lot of entity, or a lot of research teams are working very much in silo, because there are so many things to address. For example, social cultural resilience, it can be governance resilience, it can be infrastructure resilience, so on and so forth. All right, so we again agreed that this is a very broad area, but then again, if you pull these together, then we can actually just focus on four capitals in particular. This is learning from the experience in New Zealand, which is referring to the natural capital, human capital, economic capital, and social capital. I'm looking at the time now. I also like to bring attention to this very important recent report just published last year by United Nations Office for Disasters Risk Reduction. So Global Assessment Report on Disaster Risk Reduction 2019. You can download this for free. I think the most important aspect is that the scientific communities all over the world is now working more on addressing natural hazards, because by doing so, we are basically trying to approach bringing down or what we call try to reduce the disaster's risk, and therefore also at the same time creating a resilience. So I think for, if I may recommend for ETS in particular, the ocean and coastal and environmental and natural disaster faculties in ETS, it may be something good also for you to what we call revisit this aspect and try to bring in more dimensions to this. All right, so let's take a look at some of the national resilience agenda. Hopefully I can take about 3 minutes. So obviously New Zealand is there. So for New Zealand, this whole thing, they started with national disaster. The word disaster is there, resilience strategy, because we know the geographical conditions of New Zealand. So they are seismic prone. There are many occurrences of earthquakes, for example. Volcanoes are also there, and things like that. So to them, understanding and enhancing the disaster resilience of New Zealand community is their national priority. Therefore, it becomes a national agenda. There are efforts at the national, regional, and local scales to develop interventions that enhance community resilience. And eventually, by doing that, now they come out with a more generic, the Resilience Indicators Bank and the New Zealand Resilience Index. So they are not only measuring disaster resilience, but they also bring on board other dimensions like governmental, for example. So if you look here, this is the 4 capitals that I have highlighted: the natural, social, human, and financial physical capital. And of course, they also work on these what we call dimensions and how these interrelated, all these dimensions are interrelated to all these important aspects in terms of how you can measure and who are the custodians of all these what we call capitals and also dimensions. So for Singapore, all right, so they form what is known as Singapore ETH Center, which involve of ETH Zurich is university. I was in Johor Bahru, so I have visited this institution. They have a branch in Singapore, from all the way from Zurich, the ETH. There is Nanyang Technological University, National University of Singapore, and also Singapore Management University. So you can start seeing that people's experts from various stakeholders, various disciplines come on board. And for Singapore, they address, the way they approach this is they address from socio-technical point of view. All right, so I think these are all the things that is important, because as a small country like Singapore, I think they use the word something like SWOP, SWOP. S is small, WO is well organized, and P is prosperous. All right, so if I can give one good example related to this is, for example, if you look at the power supply, if electricity blackout happens, then of course it will, cascade down into other damages. All right, so it will mean the factory is not functioning, therefore it will affect their economic because Singapore relies so much on their industrialization output, in particular manufacturing and things like this. All right, so therefore it is very important for us to have a resilient system to counter all this disruption and disturbance. And for Qatar, we started by asking all these important questions. For example, the easiest one, because knowing our location in a very, I would say, volatile region, I think if you are not aware about, Qatar is facing a blockade from a few neighboring countries in GCC, in the Gulf region. So therefore, it will also affect in terms of food security, for example. We can ask questions about how is resilience capacity developed through the interplay between society and technology, again referring to socio-technical system, and also how can big data analytics help in decision making, because we know about all this digitalization, the industrial revolution 4.0, so we have to bring all this on board. All right, so this is the research grant that we have proposed to Qatar National Research Fund. So there is a call for National Priority Research Program under a thematic cluster referring to disaster and hazards management. All right, so we are working on this now, on social resilience, economic resilience, environmental resilience. I'm leading the environmental resilience sub-project number 4 there. And we also bring on board social technical resilience to address across all these dimensions. And then we will conclude by what we call creating a big database, which is a big data for resilience, which hopefully by doing this, we could be able to address sustainable and operationalizable Qatar National Resilience Framework, and of course Qatar Resilience Roadmap and resilience capacity building in Qatar. Most likely, if it's possible, we can also form Qatar Research Institute. I would like also to extend, I have a few contacts in ETS for us to work together with some colleagues and friends from ETS. Dr. Silvianita, I know for a very long time, since 2011 or 12, so we can work together on this. And of course, Professor Dr. Suntoyo and all the friends who have keen interest in working in this, what we call national resilience agenda for a country. So with that, thank you. I overshoot by 5 minutes. I pass back to Professor Engineer Dr. Daniel as the moderator. Thank you so much for listening. Assalamualaikum.
Waalaikum salam. Thank you very much indeed for a very interesting and comprehensive presentation, Professor Hamidi. Now I would like to invite questions and comments from the audience for both presentation by Professor Semedo and Professor Hamidi. Please. Pak Suntoyo, you have questions? We have 30 minutes. I think we have 30 minutes for a question and answer session.
We have question for Professor Alvaro Semedo.
Please, yes.
How is the development of wave forecast analysis for archipelago areas where the interaction between atmosphere and ocean surface is more complex?
Is Professor Semedo available?
Yes, I am, of course. This is an interesting question. So let's see if I understood. So you want to know where the air-sea interaction makes the wave forecasting more challenging. Wave forecasting is all about the wind, because winds are responsible for for wave generation. So when a wave model needs to have wind input, and this wind input comes from an atmospheric model. So the interaction between these two models allows us to forecast the sea state. Where wave forecasting is more challenging is where the challenge to produce quality winds is higher, and this is actually in the coast of Oman due to the monsoon. Wave models, atmospheric models and climate models have a hard time in reproducing winds in the Arabian Sea, south of Oman, south of Yemen. It is really challenging. So there is the area where wave forecasting and wind forecasting usually is more challenging. So I hope I answered your question. Let me add, there are areas also, so now going to Indonesia, where wave forecasting becomes extremely complicated also. Because Indonesia is in itself a continent. We call it the maritime continent. Because of the high number of, extremely high number of islands, it becomes extremely complicated to forecast the sea state. Luckily, the sea state inside the archipelago, inside Indonesia, is usually very flat. Only in the south coasts of Sumatra, Java, Bali, coasts that are facing directly the Indian Ocean, only in these areas, waves are really high. In the Java Sea and inside the Indonesia, that is not the case. Nevertheless, if we want to forecast accurately waves in the maritime continent, necessarily in Indonesia, that is also an extremely complicated task.
Okay, thank you, Professor Semedo. Is there any more question?
Yes, I have questions.
Yeah, please, Pak Sundoyo.
Okay, thank you, Pak Alvaro. I have a simple question. Which data can be used to validate with prediction based on ECMWF? Could you give me some suggestion related with this question? Thank you very much. If I want to simulate the wave prediction near Indonesian area, for example, in Java Sea, for example.
Yeah.
Thank you.
Thank you very much for the question, Pak Suntoyo, dear friend. If I understood well, you are asking me which data you should use in Indonesia, which data you should use as a benchmark to compare wave predictions that you might, or wave forecasting that you might use. That would be definitely, you can use ERA 5 or the ERA 5 Eindcast. They are both available at the European Center website. If you have problems reaching the data, because sometimes you need to be a member of the European Center Consortium, you can of course contact me, and that becomes much easier. And of course, you can compare it and validate it against modeling data, but you can also do that against buoy data or satellite altimetry data. Satellite altimetry is usually easy to find online. It takes some effort and some knowledge to process the data, but it is possible and doable. Buoy data depends very much of the place. Unfortunately, around Indonesia, buoy data is very scarce. You can find it more around Australia but definitely not around Indonesia. One suggestion, if I may, is that ITS buys, along with the very, very comprehensive instruments that you already have, and you know that, ITS should buy a portable wave buoy. They are very inexpensive. They use basically GSM technology. So it's basically a cell phone that is inside these new wave buoys. And they are very inexpensive. They cost around $10,000. They are very easy to maintain. The Paboyan that you know well, that visited ITS recently, is an expert in these buoys. He was actually part of the development of these portable wave buoys. These wave buoys were developed at TU Delft. So they are very inexpensive and really, really accurate and really user-friendly for engineering purposes.
Okay, thank you, Prof. Semedo. Any other question? I have a question to Professor Hamidi. Yeah. How do you promote transdisciplinary approach? Because usually in Indonesia, experts are very happy living their own silos. You know? It's not easy. It's not easy to promote transdisciplinary approach. What is your experience in this? Please.
All right. Okay. Thank you, Professor Daniel. All right. I will answer this because I also read there is another question in the chat box, but let's focus on this transdisciplinary. And if I can use my little experience when I'm working at University Technology Petronas, and also I think that was because I involved directly in the committee per se. And at that point of time, I think we know Petronas is like a multinational corporation, our very own oil and gas state company. So we decided not to go to the consultants in order to promote or how transdisciplinary can be applied in a higher institute of education. So we're glad we did that because we don't waste money to the consultants, so to speak. But then again, I think what we have done, to cut the long story short, we started with two main domain to work on. One is research, all right? So knowing that UTP is a university owned by Petronas. So we come up with 9 research areas, and 4 or 5 are actually working directly on oil and gas. Serving the oil and gas industry. But then again, when you say oil and gas, it can also bring on board people from social sciences, for example. One of the things that I can quickly give example, if you think about these people working at the offshore platform on 2 weeks rotation, you know, so what about their mental health? What about their psychological being and also physiological being? So with that in mind, besides looking more at the engineering aspect of it, but then again, you have to bring on board people from medical health, people from social sciences, for example, to make sure the working environment is good. So this is one aspect about what we call research. And of course, I was at that point of time working more with sustainable development, and then we come up with sustainability science, and then in order to bring more people on board, then we come out with a research group called Sustainable Resources. All right, therefore we can have more people from different background, from different disciplines, even people from management, from humanities can also join this research group. And we try to find any particular research area that we can address with this multi-prong, with this multidisciplinary kind of effort. But we have to ensure we come up with a good holistic, coherent framework in order to resolve or provide solution to any particular problem. On the other hand, the second domain that we are working on is actually in teaching and learning. So our students, especially at a more senior level, most likely at the third year or the fourth year, we can come up with, for example, some of the things that we do is engineering team project. Although it is called engineering team project, the word engineering is there, but the students can come in and design something that can benefit the consumer, us, the public users. So they can, and because of that, the group are not only comprises from students from electrical or electronics, students from in UTP, we also have mechanical, civil, or petroleum, but students from business also join because you need to know how you can market this. All right, so I think to begin with, at least at higher education institute, so you can look at these two domain, research and also teaching and learning. But obviously, this can also be applied at the facultas level, at the faculty level. So the dean between the two faculties can start talking, but it can also come from the top, bottom kind of direction. In my case, when I was at University of Technology Petronas, it was a leadership decision. So it is more top bottom, but we work on from the bottom up how this can be best implemented and suit our resources, our what we call our curriculum and syllabus requirements and things like that. Okay, so that is my response to Professor Daniel. If I can read the second question, I think from, I'm not too sure whether this is Bapak atau Ibu and Fariza Inzaghi. All right, so asking about, for example, the positive case of COVID-19 in Indonesia is still going up. The government's policy did not seem to work effectively, and the society's awareness of the danger of the virus appears to be declining over time. Is there any way to implement this national resilience framework to this sort of situation? The quick answer to it, yes. But the not so quick answer is that you need time to what we call come out with the framework of national resilience of any country. So in particular for Indonesia, I think with 280 million of population, with the vast areas of archipelagos that you have. But then again, I think in the context of national resilience, obviously when we are saying about COVID-19 pandemic, it refers more towards public health resilience. But then again, as we are aware, as people cannot go out, and if the country or the authority applies lockdown, for example, then people cannot go out to find, to work or to find their means of living. I'm referring to income, for example, then there will be a huge deterioration in terms of economic well-being. All right. I'm also referring, this is not only to Indonesia, this is also happening in countries like USA, for example, a very, what we call, I would say, developed country. But the point is that now we all aware that first, the world we live today is VUCA, volatile, uncertain, complex, and ambiguous, and therefore as various stakeholders tackling issues according to different dimensions, or I use in the slide presentation different capitals. But then again, there must be a body at the top, which most likely the government agency that try to link and find where the interdependencies are. So I think with that in mind, if this has created awareness, I would like to, or strongly encourage, especially all those intellectuals, scholars, and researchers in ETS, and whoever listening to this ISOCEEN webinar today to start pushing forward the agenda of national resilience for Indonesia. So that would be my strong suggestion. Thank you so much. I hope that answered the question.
Thank you, Prof. Hamidi. Is there any more question? Yeah. Any more question? Pak Sundayo, is there any question? Yeah. I like to. I have a question to Professor Hamidi. Yeah.
Yes.
With respect to coastal cities and tropical zones, I wonder if we could develop a kind of initiative to develop a resilient cities in those areas with potential sea level rise and possibly tsunamis, probably. Yeah.
Yes.
Some of waterfront cities in Indonesia are prone to those disasters. I wonder if we could develop an initiative to for a platform to develop a resilient cities for those waterfront cities. What is your comments, please?
Yes, yeah, I think that is a very good effort, and I think there must be a few institutions or universities in particular. Obviously, ETS, I think you are leading this for Indonesia, but my point is that as we know, this started as part of engineering systems because we are referring to sea level rise, all these aspects about coastal declinations, or also potentially because we are aware about seismic prone area in Indonesia. So if earthquake happens, the epicenter is somewhere in the sea, then highly potential tsunami will occur. All right, so this has happened before. I will not go back to, it is not a good story to revisit. But my point here is that as you work more on this engineering system, some of the things that you can do is, of course, creating the model, like, and to a certain degree, it is also something about foresighting. Some of the things that IPCC group, right, the one under climate change intergovernmental panel has done is working on scenario. For example, if global warming increased by 1 degree Celsius, what would be the likely scenario for sea level rise? What happens if it's 2 degrees Celsius? What happens if it's 3 degrees Celsius? Then obviously we aware all these are interlinked, interrelated to each other. I think this is also some of the presentation done by Professor Alvaro Semedo today. You come up with the model, but more to it, if you talk about national resilience, the engineering system is there. We understand what can happen, but at the same time, other interdependencies, what we call domain or capital or areas must also be linked to this particular engineering system. I'm referring if disaster or if hazards in this kind occur, what will happen to that particular neighborhood or community economic well-being, for example? What will happen in terms of how do you move these people? I'm talking about emergency rescue, all right? And what happened after 1 year? What happened after 2 years? What happened after 3 years? All right, so the short-term planning, the mid-term planning, and the long-term planning. I think at this point of time, I'm not too sure whether I'm saying this correctly. If we have to revisit what happened during tsunami 2004 in Aceh, then of course I would say that most likely the recovery happens. All right, so it's already more than 60 years. I think just last few months, I checked some of the images from Google Map and see that a lot of things has become better, or if I can use the word back to normal. But my point here is that if you apply or if you have in place a national resilience agenda, most likely you don't need to take 16 years to recover. All right, I think some countries has done this. Japan is always good in this. When I was living in Fukuoka, I have also experienced earthquake, which is quite strong, 6.8 scale Richter. But then again, things back to normal just within 1 week, because they have everything resilience, what we call a framework in place. So I think this is some of the thing where countries and authorities of that country, and also researchers and intellectual people or scholars can start working on. And I would again, Professor Bapak Daniel, for Indonesia or for ITS in particular, to start pushing this agenda. I hope that answered the question.
Yeah. Thank you, Professor Hamidi. I think the time for our session is up. I would like to return back to the session for the Ibu Sadi or Mistress of Ceremony. Yeah. Please.
Thank you.
Yeah. Thank you. Assalamualaikum.
Waalaikumsalam.
Thank you very much to Professor Daniel Rashid, Associate Professor Alvaro Semedo, and Associate Professor Technologist Muhammad Faris Hamidi. A very insightful presentation for all of us, and thank you for sharing. Ladies and gentlemen, I believe that today's agenda for the first day of ISOCEEN is already completed. I hope you have found today's presentation and discussion informative and useful. Thank you for spending time with us today, and see you tomorrow on the second day of ISOCEEN 2020, where we will continue with parallel session started at 10 a.m. Please join the corresponding room by clicking the link that has been sent to you by email. Thank you so much for your cooperation.